Yeah, last class before the mid exam, we already learned how to traverse. Did you still remember what is the meaning by traverse? Traversal means we want to visit the node, and there should be a systematic manner to visit the node. So we have known the pre-order traversal. A node is visited before its descendant. So we visit the parent first, and then visit the next, which is on the left, and then visit on the left. After we finish with the left, we go to the right, and then if we finish with this one, we go to the next sub-parent, and then left to the right, and then return back to find the right one, and so on. So this is the pre-order traversal. And we can have a very simple pseudocode like this one. This is the pre-order. V is the vertex. First, we visit the vertex. It means we visit number 1. For each child, so we have the first child, the second child, and the third child. So we will visit the W. In this case, we visit the W, which is 2. And then we will do recursion, pre-order. The pre-order means we will run the algorithm pre-order again. And then it will check. Now it will visit the number 2, and then we will check again for every child. For every child, here is the first child. Then again we will do pre-order. When we do pre-order, we will again visit. So when we visit, then after we finish, we will check, is there any child? There is no other child. Because there is no other child, then we will return back to the parent, and we will check another child. Another child is this one. Then we will visit. And then is there any child? This one? No child. Then it will return back here, and then it will return back to the parent. Okay. What about the post-order traversal? In the post-order traversal, a node is visited after its descendants. It means we will check the descendants, and then we will put the confirmation we visit. So in this case, we have post order. We will check the child of this V. Okay, we have child, we have child, we have child, but we will do this one first. And then we will check, is there any child of 3? Yes, we have the child, and this one is the child. And then we will do the post order. Is there any child? There is no child. Then we will like check in. So we will put the notation visit. So we'll visit this one first as the number 1. And then because we finish with this statement, we will return back here and check from the next iteration. What about the other child? Yes. Is there any child from this one? No child. Then we will do the check-in or visit. And so on until we finish. Because there is no other child, then we will return back to the parent, and then we will visit this one. After we visit this, we go to the next child, because there is another child, so we go to this child. Is there any other child? No child. Then we will visit. That's the difference between the pre-order and post-order. And when we do with the binary trees, it means we have the tree and the internal node has at most 2 children. 1, 2. And then 1, 2. 1, 2. Exactly 2 for proper binary trees. So if we have exactly 2, this is the proper binary trees. But if it is, for example, I have node, and then I have only on the left, okay, we call it, this is at most. What does it mean, at most? Maximum 2. So it means if only 1, this is also okay. However, exactly 2, it means, yeah, every node will have 2 nodes, 2 child nodes. Then it means the proper binary trees. And the children of a node are an order pair. Order pair means we have the order left first, right next. We call the children of an internal node left child and right child. So this is the left child, this is the right child. There is an alternative recursive definition, okay, whether a tree consisting of a single node or a tree whose root has an ordered pair of children, each of which is a binary tree. So I have a parent with 2 nodes, and again this is a parent with another 2 nodes that can be referred to the recursive. So it means one parent have 2 nodes, one parent have 2 nodes, one parent have 2 nodes. It can be the recursive. Or if the tree is only consists a single node, then it's the recursive. There are some applications for these binary trees. We can use the arithmetic expression or the decision process or searching. Let's say the arithmetic expression. When we do the arithmetic operation, like making a calculator, when you make your calculator, you can use binary tree. The internal node is the operators, and the external nodes are the operands. Operands, this one, 2, A, 1, 3, B. So those are, we call it operands. Operators, we call it the multiplication, minus, plus, multiply. So those are the operators. So if we have the arithmetic expression like this one, then we have to multiply a minus 1 plus 3 multiplied by b. Okay. So this is using the post-order traversal. This is the binary tree. The other kind of tree, you can use the binary tree with the decision process. So if you learn machine learning, or if you learn the data mining stuff, you will have what we call as the binary classification. So in the binary classification or the binary decision tree, it is using the idea of this tree. The binary tree associated with the decision process. So the internal node is the question with yes or no answer. Yeah, maybe for the simple one, this is just yes, no. And the external node is the decision. So I want to know what is the decision. This is the external node. So for example, yeah, I want to know your decision about your dining. Dining is like, what do you want to eat? Okay. Do you want a fast meal? Maybe do you want to have fast food or yeah, very quick food? Yes. Okay. If it is yes, then there will be a question again. How about coffee? Okay. Yes. Okay. Then you can go to Starbucks. Or if you do not want coffee, you can go to Spike. Spike is a restaurant in US. Okay. So it is only a very slight meal. If you do not want fast meal, okay, then it will go to the right. And on expense account, so you need to consider the amount of the meal. Oh, sorry, the price of the meal. Okay, if you consider the price, you can go to Alforno. Okay. This is the name of restaurant in US. If you do not consider any price for the meal, maybe you will have a very fine dining restaurant, very luxury restaurant or something. Yeah, this is just an example. Okay. Now we need to understand the properties of binary trees. How we can say that it is the proper binary trees? You still remember what is proper binary trees? Proper means exactly two. Okay, so if the internal node has exactly two children, then it is proper binary trees. Okay. Now, let's suppose we have the n as number of nodes, e is the number of external nodes, I is the number of internal nodes, and h is the head. Number of nodes. So how many nodes we have? 1, 2, 3, 4, 5, 6, 7. Okay, we have 7 nodes. What about this? 1, 2, 3, 4, 5, 6, 7. Same 7. But the structures is different. So the properties will be something like this one. E will equal I plus 1. What is E? E is the number of external nodes. What is external nodes? We call external node is the leaf. Okay. What is leaf? Leaf is the note without children. If you still remember the definition. Internal note is note with at least one child. And external note, as known as leaf, is note without children. Okay. It means I. What is I? I is the number of internal nodes. So in this case, I have 1, 2, 3. Then 3 plus 1 equals to E. E is the external node. 1, 2, 3, 4. Okay. And then we have N equals to 2E minus 1. N is the number of nodes. 2 multiplied by E. What is E? E is the number of external nodes. External node we have 4. 1, 2, 3, 4. So 2 multiplied by 4, which is 8, minus by 1. Then it equals to 7. H is less than equal to I. H is the head. What is the head here? 1, 2. What is I? The internal node. We have 1, 2, 3. Okay. So the head is 2 is less than equal to 3. What about this? We have 1, 2, 3. So it means 3 is less than 3 because the number of internal nodes is 3. H is less than equal to n minus 1 divided by 2. What is n? Is the number of nodes. So 7 minus 1 divided by 2. 10 is 3. H, we know that if it is like this one, the structure, then it equals to 2. H equals to 2. For this structure, H equals to 3. So it's similar with this one. Okay. And E equal less than equal to 2 power of H. In this case, H equal to 2. This one, H equal to 3. What is E? E is the number of external nodes. We have 1, 2, 3, 4. So in this case, we have 2 power of 2. 4 is less than equal to 2 power of 2. But what about this? This one, E is the number of external nodes. We have 1, 2, 3, 4. Okay. 4 is less than equal to 2 power of H. H equal to 3. So it means 8. Now, H is greater than equal to log 2 base log base 2 of E. What is log base 2 of E? E is 4. Log base 2 of 4. The result is 2. Okay. Then H is the head. Okay. The head is 2. Yeah, in this case, 2 is greater than or equal to 2. Okay. And this one, 2, n plus 1. N is 7 plus 1, then 8. Log is 2 of 8. Then it is 3. Okay. 3 minus 1. Then it is 4. So X is greater than equal, sorry, 3 minus 1, it is 2. Okay. Then the X is the head is greater than or equal to 2. Okay. So those are the properties. Yeah, you can deal with this one. Okay. So in the binary tree, you can have some methods. Okay, I think it's the time for break. So let's have the break, and I will continue after the break.
Sure.